Okay, here's the completed transmitter receiver tester that I built, and it's Arduino Nano based. It's got MP3 player there, and that's what it looks like. It's running a 1.44 TFT screen. Let's turn it on. We'll take a look at it real quick, and then we'll take it apart and look at the inner workings of it. And it's a countdown timer, and you can set the receive time and how long you want it to sit and receive. You can set the amount of time that it transmits. So we'll set this down to 1 and let that count out, and let's hook up a speaker real quick. Okay, we have a speaker connected to it now, and it's going to and of course, you know, you have to have the transmit time set properly. I think that 1K tone is like 10 seconds, 9 seconds, somewhere right around in there. And then it'll come back and it'll start counting down and do the thing all over again. One of the other features to that is this button. And in case you don't want to wait for the timer to count down, you press this button and it will force it into transmit mode. Play your music just like it would if the counter was running, and then it just resets and then resets the counter. This right here, this selector, allows you to select between two different audio files. So if you wanted to play a 1K tone, you could have it set here. If you wanted to play another tone, you can remove the jumper and put it back on, and it will allow this resistance to go through to the MP3 player and tell it to basically play a different track depending on the resistance that you have in the line. Let's take the speaker out, and we'll take this thing apart and take a look at it. Okay, here we are all apart, and you can basically see the insides of it. Here we just have our switches and our screw terminals for our relay contacts. And as far as wire management goes, just used a couple pieces of wire, soldered to the board, jump over the wire, and just kind of made it look a little bit pretty. And over here is a 9-volt battery. We have the two caps for the voltage regulator coming off of the 9 volts on the Arduinos, the Nanos, for some reason, running 9 volts into it. With this MP3 player, it likes to have clicking, causes clicking in the speaker, because the 9 volts not play well through the Arduino's regulator, the 5 volt output to this for some reason. Maybe just because it's a cheap Chinese clone or what, I don't know. So I added a 5 volt regulator, which is underneath. Here's the caps for it, and basically we're just sending 5 volts to the Nano, and that is powering everything. This is a DF player, mini MP3 player. Of course, we've got our 5 volt relay, our on-off switch, and over here is a reset switch, so you can reset the unit because it's too difficult to get in to the reset switch on the board. Okay, we got it back together, and I'll take the bottom off. Just want to throw a quick tip in there. Anytime you're working on any of your stuff, and you've got an LCD on there, or TFT or display of any type or whatever, and you're going to have it upside down, I always just take a piece of painter's tape and place over the screen like that, so when I flip it upside down, I don't scratch it up and mar the front of it and make it look like crap. Now time for some high-speed removal. to protect the mess that is the wiring underneath, which isn't that bad. I tried to do a little bit of cable management, make it somewhat distinguishable, but yeah, you can see how well that went. Oh, right here is the 5-volt regulator that's going over to the capacitors right here, and it's just a surface mount, and you can get 100 of them for $3 out of China, and they work pretty well. Okay, so that was the gory details on the inside and the guts and everything that makes it work. I'll post information to the GitHub for the code, and try and post some links to the parts that I bought out of China. Now up here, one of the things up here is the outputs for the. Let me get my pen here. So this right here, these two here are for the audio. This audio goes out into the transmitter, so that when you're doing it, you're broadcasting your test tone or a message. If you're having to do it live over the air, which you shouldn't be doing in the first place, that'll put audio out so that you can figure out if the radio is actually transmitting audio or if it's not, because that's a big problem. Just keying up the radio, you can't tell if the audio circuit's working like it's supposed to. Here's the PTT. This will connect to the radio, and this will actually tell the radio to transmit. Just closes the relay on the inside, ground in one side, and the PTT wire out on the other side will key the radio. This over here is for future use. The intent is it's labeled receive. I want to bring a pin out of the radio with a that's got received signal on it. Will go here, and it will then, the Arduino will then do math inside and figure out what's going on, and when it detects a signal here, it'll go, hey, the radio is receiving, I don't want to key up, and I'm going to stop the process. And once you do, then it does, it will then flash up here, receive, and stop all functions until that receive signal goes away. Then it will turn back to normal operations. In the conventional world, this will just key up and play your audio over somebody else. You may not want to do that. In the trunking radio world, if your system's set up properly, such as ours, if this goes to key up, it will just bonk the radio and won't allow the radio to key up because of the radio's already receiving signal. But even though that safeguard is there, I want to make sure that this unit here doesn't have the ability to do that. So that's it. If there's any questions or comments, likes, dislikes, or general criticism, feel free to put it in the comments below. I will do my absolutely best to answer any questions. And thank you very much.